place. This course is an introduction to Git for version control. It is very much an introduction. So it's an introductory level workshop. We assume that everybody in here, the assumption is you have no prior knowledge about Git, haven't used it before, so this starts at the beginning and moves up. But you do have to have some prior knowledge of your computer. That will be very helpful, which not everybody actually has nowadays because search has gotten so good. But we'll go over this together in practice to make sure we have it, which is basically how to navigate your own file system on your computer. So how to find files that you have saved on your computer using either your Mac Finder or Windows Explorer or whatever navigator of your choice on your computer. And the topics that we will cover will include a basic introduction to Nix. I'll say Unix, but that basically applies to any kind of Unix, Linux environment. Command line, when I say basic, I mean basic. Just some very basic things that you need to do to be able to navigate your file system and to execute Git commands, because we're going to work from the command line to engage with Git today. So we'll cover that. And the basic purpose and function of Git for version control. So just that basic, and I should have added really there for local control, right? We have a for teams, as Tamala said, workshop coming up in a couple weeks. That's when we will cover really in depth working with remote repositories and workflows around collaborative coding. So this workshop starts with just the basic practice. Before you can do that, you have to actually be able to work with it locally to just manage your files locally. So the learning objectives for this course, and just time check, 4 o'clock is our close window, right? Just to make sure I'm on time. Okay. Our learning objectives for the course are that you should be able to navigate your computer's file system using a terminal application and Unix command line stuff. So these are all things we're going to, if you don't already know how to do it, these are things we're going to learn. You will be able to do when you leave this workshop. Understand what version control system is and describe the benefits of working with one, right? So it's kind of imperative if we're going to do something, it's nice to know why we would want to do it. And so we'll get into that a little bit. You will all install Git version control system. So you will leave here with it installed on your system if you want to follow along. So this will be the beginning, a little more talk than do, but for most of the workshop, it's going to be, we're going to do stuff together. You'll be on your computer, hands-on doing stuff. In order to do that, you need to install Git. If you don't do that, then you'll just have to listen and try to remember, or watch the recording and do it at a later time. I promise you, Git is safe to install. It's well tested. Everybody uses it. It has a very robust open source community of developers. So I don't know what will I want to bet as a security risk. I'll buy an expensive dinner for anybody in here if installing Git actually creates a vulnerability on your computer. I feel that it's safe. Describe the Git system architecture and file structure. It's crucial to actually understand how Git is doing what it does in order for you to really maximize it and use it to its full potential. Describe the primary components of a workflow that will go around Git. We'll know how to create a local Git repository, how to track individual files locally, how to perform basic branching and merging, how to compare files within the Git system, how to roll back changes to earlier versions. One of the things that we'll get into, benefit of version control, is I can go back and look at earlier versions and then say, oh, that's actually the one that I want to be working with. And how to recover from some common errors, the most important one being, which eventually somebody in here will see, probably multiple people will see, is the dreaded detached head state. You'll get an error that says that, and it won't let you do almost anything until you solve that problem. So we'll learn how to solve that so that no one has that barrier. So that's what we're going to cover. So the big question, first thing, is just why version control? And this is sort of my list of the primary reasons why version control is a good idea and why really everybody should use it for just about every kind of file that you work with. And I mean that quite seriously. And we'll get more into file types and stuff as we move into the class. But essentially, the big thing, starting from the more global things and then moving to some more local things, is it guaranteed will improve the research validity and accuracy of your work. When you have good version control methodologies, that gives you the ability to actually remember what was it that I did with that thing 6 months ago, and how did I get to that next instantiation of the data, where we forget, and then you think you're running analysis on one thing, but you're actually running it on something completely different, or you have a whole chunk of 5,000 lines of code you wrote that you think are doing one thing and you forget that you made some change to it, and now it actually is producing a totally different output. This happens all of the time. Research is plagued with these kind of errors, and version control solves that. Okay, I should be up front. You'll see as we move through here, it takes a little extra work in the beginning, and as you go along, like as you're working, there's a few extra steps you have to do to be engaged in the good version control workflow. Git isn't just something you install and it magically solves this problem for you. But in the long run, it is guaranteed to save you time and improve your accuracy. It will improve research reproducibility, because when we have well-documented versions of things in code, then we can include that in our publications, or when someone asks, how was it that you did that? You're able to actually go and say, well, this is exactly the file I used at that time on that data to produce that, right? So it really, really speaks to, a major issue in the academy and in scientific research in general, all kinds of research really, which said it should be reproducible. And you can't do that without good version control and documentation. Part of that, and I already alluded to this, is that it will help you remember why you did things. If you do it well with a good version control system, you will not find yourself again in that situation that we have all found ourselves in, where you go, yeah, why did I do that? How did I get, like, what was going on when I made that change to it? Because you did it, and then you moved on with your life for 3 months, and then you were in a lab meeting, or now you have some publication you want to do, and for the life of you, you cannot remember how you got, where you got, and why you made a decision, right? So trust me, the older you get, this will get even more important. So establish the good practice now and set yourself up for a lifetime of benefit. And again, this will lead to long-term time savings. It's going to feel a little intrusive in the beginning, but once you master it, you get used to it. And over the long haul, it's way faster, because you don't have to go through all this process trying to recreate things later on when it comes time for publication or to defend your dissertation or that type of thing. Importantly, we're not going to get too much into this because that's the team for Git workshop, but one of the most significant things is it facilitates team research. As a version control system, Git, which is the system that we're covering, is specifically designed, and one of the things that makes it different from how other version control systems work, and there are a lot of them, is that it's really specifically designed for team collaborative work around the same set of documents. It's very robust systems for letting two people even edit the exact same document at the exact same time, and make sure that you don't end up with overwrites and that everything is copacetic in the end. So that's a huge advantage. Again, though, that learning how to do that more is part of our second workshop this quarter. And then finally, if you do all these things, it will restore you to sanity, right? It will just make your life that much better as a researcher in any domain. We may have to try to scrap for some more chairs. But other than that, I think we're going to be okay capacity-wise. Okay, so that is why we are doing this. And I can't emphasize enough that if you really do take the very short time that it takes to get proficient in this, your future self, just a year, 6 months from now, will thank you, like, for doing it. It is very much worth it. So what is version control as a broad topic? And I want to throw out the general definition that it is a method of tracking changes to a given document or a set of documents, okay? And I emphasize method because it's not just like a piece of software, like I said, that does something. Actually tracking things involves a lot of kind of things. So the keywords here, change. Change has many meanings. Is it every atomic change? Every time you add a new letter to a document, is that a new version? Right? Every time you change a new word, every time you save the document, like, what do we mean by change, right? That has to be defined. What does tracking mean? Is it just storing copies of them and we're done? Or providing documentation that describes each instance, provide means of understanding the differences so that 6 months later, a year later, 5 years later, you can go figure that out, right? You have to figure that out as part of your workflow. How are you going to implement the software? What are we going to track? How are we going to document it? What are the workflows around that? And those workflows are just as important, if not more important, than the software itself, right? You can install the software, use it poorly, and get virtually no benefit, right? But if you install the software and have some workflows around it and use it well, you get a tremendous amount of benefit. So you need to think about version control in that expanded sense as a set of decisions and workflows around these differences. Good version control controls file instance, storage, documentation, and regularized workflow, right? All of those things are going to be part of our version control system. Now, just to reiterate, there are many, many options for version control out there. We are focusing on Git. If you haven't started downloading Git, again, if you go to git-scm.com/download, you'll get a link to whatever is the right one for you. You can start downloading that now so that we can move along. There'll be another slide that shows that URL too. But there are tons of other. These are just a short list. I mean, there are thousands of version control systems out there of ones that are actually still currently in pretty wide use, although Git is by far right now the most widely used in terms of new adoptions. Mercurial and Subversion, because they were around for so long, have a lot of legacy things in them. But almost no one starts a new Mercurial or Subversion system. Git is kind of where everybody is. There's safety in that. It means it's going to be around for a long time, and it means it's safe. So that's what we are going to focus on. Why we focus on Git, again, it's open source, so it's free, that wide uptake. And even though we're not covering in this class, that distributed nature, that is really designed for team science ultimately. And so you can use it both individually and in a team. So the prerequisites that we need, and then we're going to start diving into some activities here. Before you can use it, you have to truly understand your file system in a way that a lot of people don't. I know that sounds silly when I say, hey, go find a file. Everybody says, I know how to do that. But we know from experience that a significant majority of people nowadays, the way they find a file is they just search for it, right? That they don't have like organized structures for where they're saving things in folders. That's sort of going by the wayside in a lot of the universe now. But you need to bring that back in order to work effectively in Git, is file organization and documentation. So we're going to just cover that a little bit. And then again, some basic Unix commands that you need to be able to do to navigate the Unix command line, which we'll cover. And we'll do a very, very brief, I mean, super brief high-level intro into this Unix native, pretty much it gets distributed with almost every version, text editor called VI or Vim. And the reason we do that is because the way Git works in most systems, probably for everybody here, there are certain things that you may do that could accidentally land you in VI. And then if you don't have any idea what to do with it, you will just be lost and stuck. So we always introduce it and we'll all work in it a little bit so you get some base familiarity, and that will make your Git life much easier knowing something about how to work with VI or Vim. Okay, so with that, we'll just dig in more. Is everybody who has not downloaded Git itself yet? Is there anybody out there who does not have the Git software downloaded? No, everybody's got it. Perfect. Okay. Has everybody started the installation? Okay. If you're on a Windows system, did you accept the defaults? You want to make sure you accept the defaults, and most importantly, you want to make sure that you included Git Bash as part of your install. It will happen. That's the default. So don't panic if you already hit. If you just click through 20 clicky disease and just said yes, yes, yes to everything, you are perfectly fine, right? But if you're still running your install on Windows, on Mac, you don't deal with these problems. But if you're still running on Windows and you get to the screen, click the Git Bash option so you get Git Bash. Okay, who does not have, now one thing I should say, when you run that install, it's going to look, except for Git Bash, like nothing happened. You will not find Git on your system. It'll just kind of end. Depending on your system, you may get a message that says I'm done, or it may just, looks like it just stopped and you think it errored. As long as you didn't get an error, it actually worked and it's probably there, right? So is there somebody who doesn't have it yet? Raise your hand so we can make sure you get it. Perfect. Okay, so everybody's locked and loaded, ready to go. Okay, so now that you have the software, that's the only thing you need to download. The first thing we're going to do is start, though not in the command line, and just start with our basic file system itself and navigate it the way most people are used to navigating it, which is some kind of Windows-based system. On a Windows machine, people should recognize the Windows Explorer, File Explorer. Depending on your version of Windows, you can get to this by the little icon down on the bottom left, or somewhere at the bottom there'll be a link to a Windows Explorer. Is there anybody who does not know how to launch Windows Explorer on a Windows system? Okay, no, good. Okay, if you're on Windows, go ahead and open Windows Explorer. You should see a screen that looks something like this. If you're on a Mac, it'll be your Mac Finder, which looks something like this. Is there anybody in here who's on a native Linux system? Anything other than Mac or Windows? Okay. What are you on? You're on Linux? Yeah, okay. I'm assuming, but if you're already on Linux, I'm assuming you know enough to know how to navigate your system. So, okay. So everybody else though, and on Linux anyway, if you want to follow along, launch your Explorer so we can take a look at it and see it. Now, actually, I don't want to show this one yet. If everybody, whether you're on your Finder or your Mac or Windows, you'll see on the left here this nav system. Somewhere on your Windows one, you'll see primary drive C. Everyone should see that. And on your Mac, you usually will see something like where we're ultimately going to get to. You used to see a thing called hard drive over here. I always add mine back in, but most people don't probably see that. Somewhere over here, you should see something that has your username on it. Like mine is Stahmer or whatever you use, but you should have some folder here that's for a home directory. So does everybody see that on their computer somehow? Okay. If you're on, the goal of the game right now is to get everybody to their home directory within Windows File Explorer. Okay. If you're on a Windows system, you're going to have to, oh, what happened? There we go. Depending on your Windows system, it's going to be in that C drive. You're going to get to a users. You have on very old systems, you have profiles or documents and setting or a users directory and then your username or a home direct. Oh, no, we're already in Unix for home. So somewhere in there, if you navigate down, you should be able to navigate to that. On a Mac, it looks like, because I'm on my Mac, this is taking a long time to get out of here. This is going to be problematic. If I launch a Finder on my Mac, this is my screen on a Mac, and I can go to Stahmer, which is my home directory, and click on it. So if you're on a Windows, you would go to that users and find your home directory. Who's a Windows user? Is there another easy way in Explorer to get to your home directory? Does it show up in your left menu somewhere, Arthur? No, I don't think so, right? Yeah. You have to go start with your C drive, go to users, go to your name, okay? Yes, then you can bookmark it and bring it in there, which you may or may not need to do because we're going to mostly work command line, but it'd be useful to have up for this course. And then you'll see all kinds of folders. Everybody's computer is going to look different. Once you're in your home directory, it's going to look the way it's going to look, right? But these files, once you're there, so just keep that open. I'm going to flip back to a slide deck real quick, but I think I'm not going to go to a normal slide view because it takes too long to click between. Let me just go to my PowerPoint. And we'll just look at it in this view. Can everybody still basically see what's going on here? It's a little bit smaller, but it's a lot. It takes a long time with the zoom to click back and forth between my deck and my actual computer. In that view, you've navigated through a tree system, right? Folders, and here's the part where unless you actually are used to organizing folders, people aren't used to thinking of them as trees because they're just searching for them all the time, right? But actually you have a root, C, your C drive on Windows, it's HD or something usually on Mac, although you can't see that it is, most Mac users at this point. When you clicked on your, like for me, it was users directory, and then there's a Stahmer directory, and that's my home directory with all of my files, right? On your Windows, it's C, then users, then if I had my Windows machine, Stahmer, and then all of my files, right? That's the structure. On Unix, works the same way, and this matters to you even if you're on a Windows or Mac machine, because once you get on command line, a lot of our stuff looks Unixy in every environment. We have the same thing, but instead of having HD or C:// although in Git Bash you can use your C:// and it will work, in pure Unix, we just have a slash, which stands for the root, whatever the root of the file system is, and then a path that leads down to users, Stahmer. Depending on my system, this could be home, Stahmer, and down, right? They move on. We call that tree structure, and here's the part that does matter for everybody, regardless of the system that you're on, a file path. And so the file path, as we would write it, I'm going to have to go to slide view because I don't think you guys can see that well enough in that view. You need to be able to construct file paths as strings. in order to function in this universe, right? So the path from the root of the drive, whatever it is, to users, Stahmer, to a file called hello text on a Mac actually looks like /volumes/hd/users/Stahmer/hello.txt. On a Windows, it looks like C://users/Stahmer/hello.txt. And on a Linux or a Unix, it looks like users or home/Stahmer hello text. Just the single slash is what starts it, okay? So you need to know that. You need to know how to construct a file path to get to a particular file in order to function in this environment. So that's the key takeaway from these slides, right? It's just that those file paths become important. There's one thing I should have put it on a slide, but I did not. There is a shorthand that will work in almost all contexts. I say almost all because there's a little bit screwy with some Windows systems, but for the most part, this will work. Where no matter what my system, that's users, Stahmer, or you know, that's HD, volumes, whatever. This is just, you know, on a Unix box, home, Stahmer. Kind of doesn't matter what system you're on. C://users, Stahmer. There's a Unix shorthand for my home directory. The home directory, which is just a tilde. So if I just went a tilde slash, that is a shorthand path to that directory, no matter which system I'm on, except for a few Windows systems which act squirrely. And you may have to always type your full path in. But we'll see that, we'll use that a lot, because a lot in this class, I'll say, get back to your home directory. Do something in your home directory. The easiest way to do that is just use this tilde character, and that is always home, right? And then you can move out from there. Okay, so keep track of that. All right, so now, we're gonna dig in and we're gonna do a little bit of command line-y stuff. Actually, I take that back. First thing I want people to do, just as a matter of practice, you should be able to find on Explorer, to navigate around to either a applications folder on a Mac or a programs folder on your Windows. This is just to just make sure you feel comfortable. Once you get there on your Explorer, you should then be able to navigate back to that home directory. These are just some things, you know, the last file you saved before. The idea is right now, go to a couple different places using Windows Explorer. The reason is because the next thing we're gonna do is we're gonna do this in the command line. And I want you guys to be able to click back and forth and look at them in both contexts, the one you're familiar with and the one you're not familiar with, so that you can actually see what's happening in that change. So the key part here, and at the end of the day, I want everybody to end up in your home directory, right? Whatever, for me, it's that Stahmer directory. Get to where you are. And for each of these, you should be able to construct a file path. Write it down somewhere. When you go to each of these things, and I know this seems very basic, you should do it, but write down, construct a file path somewhere, just a notepad or something, because you're going to use that file path to try to get to that same place in your command line, okay? So I'll wait just a few minutes for everybody to get to each one of these and then write down the file path for these two, so that you have those at your disposal and you're able to get there. If you already know where they are, then you're ahead of the game. You don't have to do it. But for those people that haven't done it, do it, and then again, write the path down, which will again look something like this, depending on your system, to get there. You don't need GitHub. No, just Git.
And when you install Git, there's like a million questions that are like,
just take the defaults.
all the preferences, you just
take the defaults, it'll work, yeah.
Oh, because it's on.
Yeah. Okay. Is there anybody who doesn't have file paths ready to go? If you don't have file paths written down somewhere, raise your hand. Otherwise, we'll move forward. Okay. Perfect. There you go. Good job. Thank you. Everyone puts their sticky up. I will tie my shoe. Okay. Yes. Yep.
So I see, depending on how I
So that's a really good question. Yes. We're so on if you're on Windows, the backslashes may be your appropriate response. What's happened is the internet brought on the /. Prior to the internet, everything was always backslash. It was like // and everything was backslash after that. But a lot of systems now, because URLs work by //, they will accept the /. So if the / doesn't work, on a file path, immediately go to backslash. But for Unix and the Mac, it's always /. Okay, it's only Windows that will stick you on that backslash world nowadays. Okay, everybody's ready, I think. Yeah.
just about the // and backslash, because I know when you copy a file path from Windows,
It's giving you backslashes.
Yeah,
and
and
that's
you have like the double one. Does it have to be in that format?
no. But if you copied it from Windows Explorer, that path with the backslashes is perfectly good in Windows, right? So if you know how to do that, yes, that will totally work. Backslashes are the original file path designators, but then URLs came along and // and the whole world kind of forgot about the backslash. Okay, so everyone has that, good to go. Okay, so now we're gonna start to do is we're gonna use those to start to move around on the command line. So here's where for some of you, this will be a new experience. If you're on a Mac, what you wanna do is find an application called Terminal. On a Mac, it's in your applications directory. There's a folder called Utilities. And in Utilities, you will find an application called Terminal. So I will go ahead and navigate there on mine so you can see it. If you're on Windows, once you finish installing Git in your programs, if you go to the Windows Explorer and go Programs, you should now see an application called Git Bash. And what you want to do is launch Git Bash. So on my Mac, if I go Finder, somewhere I should have some applications, Utilities, Terminal app, and that's the one you want to load. And because if you're going to do this a lot, this will become something you use all the time. You can see I actually just have a terminal in my dock because I use it all the time. On the Windows box, before I click back to it, it'll look, when you launch Git Bash, it'll look something like this, right? And again, if your Git install went correctly, you should see Git Bash in your programs folder, okay? If you don't have Terminal or Git Bash running, pull your blue sticky down and put a pink one up so that we know that it's not working. Otherwise, cool. Looks like everybody is good to go. Okay. Just to give you a little bit of a heads up, but don't try to memorize this or anything, because we'll go through it and you're going to type these in and use them and see what they all do. We're only going to go over a few Unix commands. What is it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, about 11 of them that we'll work on right now. It's very much just introduction to command line and really just what you need to be able to do to work effectively with Git. And those are them, but we'll just roll through them, and I'm going to pull up my terminal and we're just going to finger code together. When you launch Terminal or Git Bash, we'll just call it your terminal window. Typically, it's configured so that it always lands you in your home directory. But just to be safe, I'll introduce a first command in Unix, which is called pwd. Let me zoom this window up here so that you guys can see better what I'm typing. Plus. There you go. Can everybody read that? More? Say when it's good. Does that work? That's good. Okay. So pwd. Now the way Unix works is you'll always see something up to like a $sign or a %sign. That's what we call the command prompt. And then it's asking you to type something afterwards. So this is my blank where I haven't typed anything yet, and I just have a cursor there. And it's return is what executes something. So you'll type a command, you hit return, it will execute, right? the first command we're going to use is called pwd. It stands for present working directory. I'm going to hit return, and it's going to give me the full file path to where I am in that moment. Okay, this can be very useful because it's very easy to forget where you are in any moment, right? And so you can always get reoriented. Now it turns out I'm already in my user Stahmer directory, which is where I want to be and where we ultimately want to end up. But just in case somebody isn't there, because it depends how your system is natively configured, I'm going to introduce a next command, which is the cd command, which is for change directory. We go cd space, and here I'm just going to use that tilde character, my little shorthand. And when you execute that, that will definitely put you into your home directory, right? So I'll pwd again, and I'm still where I was because I was already there, but you might not have been. So if everybody executes those, you'll know you're in your home directory. All right, we all good and happy? Awesome. Okay, now let's do as a first step, another command I want to introduce is ls, which is short for list. If we type ls list, what that does is it gives us a file listing of all of the files in that directory. Because I'm very zoomed in, you can see it rolls down. I have to scroll to see them all, right? Now, real quickly, what I'm going to do is this. Oop, that's not what I meant to do. There we go. I want to put these side by side. If I put that there, and everyone else can do this on their machine too, and then I'm going to load my Finder to my home directory, Stahmer. And you can see that what I have here are two views to the same thing. In my home directory, I've got an applications folder, that's my Windows view of it. And I've got an applications folder, that's my Unixy view of it. I've got valid authorship. Oh, already we see a difference. Unix is going to put all the directories at the top in most instances and then move to files, right? The next directory I have is BoxSync. I see BoxSync, Creative Cloud Files, DH Cluster, you know, and notice also, who can tell me else what's going on here? Why did that start to look different again? Who can see a difference? Case sensitive, right? The Unix is ordered case sensitive. So these are lowercase, these aren't there. The next one is downloads, is Dropbox. But if I start scrolling down, after I get through all of the directories in case sensitive, I'm going to start to now get to directories lowercase, valid authorship, right, and then files and so on, right? You know what I mean? So you have to, you know, the ordering is slightly different, but you see what we're doing is getting two views of the exact same thing. Is everybody able to do that? Okay. Now, I'm going to do some more thing, and here's where we start to get to do our first little hint of Unix magic. There's a way with many Unix commands, they have flags, things that you can set that tell them to behave in different ways, right? I can do what's called ls, my list command that we all just did, and everyone go ahead and do this with me, -a, and the A stands for all. Hang on, let me scroll this up a little bit so that you guys can, I'll clear out the junk, and I'm going to do this. So it's higher screen. Can everybody see that last line now better? ls space -a. So it's ls space, and then the flag is a dash and an A, right? So it stands for all. And here's something's going to happen. When I run this, and I'll scroll to the top of that returned list. So here's where I ran it. We see all of these, and let me just expand this again a little bit. We see all of these files, and everybody will see this. Your list is going to look different. All of these things that begin with a period that don't show up in your Explorer or Finder view. You cannot see them. They're called hidden files, right? They make the computing world go round. All the best stuff lives in a hidden file of one kind or another. Being able to get to these hidden files and then later on even to manipulate them is gold, man. That's like the first step to super user, because there's all kinds of things in them. Now it also can kill your computer. So you have to be careful what you modify, but it gives you this look under the hood of things that you don't actually ever see in your normal world. That's one of the first reasons why we go command line, is because we just want to get to the real thing, what's actually on my disk, not what did the makers of Windows or the maker of Mac think it was important for me to see that's on my disk, right? You can actually see all of the files that are there, like your real history, all of that. And we do that with that .a command. A couple special things that will always show up are a single dot and 2 dots. In Unix land, when we're constructing file paths, a single dot, just like this is shorthand, I'll get rid of that and we'll just write it all from the top. Our tilde is a shorthand for home. A single dot is shorthand for the present directory. And 2 dots is shorthand for the parent directory or folder. I'll use directory, that's more Unix speak. Folder is more regular. So if I'm moving around my file system, I don't necessarily have to know, well, what was the name of that file path up above. I can just say cd ... and it'll just move me up above one, right? You can just refer to it that way. Dot, I can just do relative paths like ./file.txt is just a bulletproof way of saying a file in the current directory that I am in, or that this script is executing from, right? And it's a relative path, not a full path. So those are shorthand. They will always show up, but then we get all of our nice hidden files, and we're going to really need to see those as we dig into Git itself, right? So let's see, we've CD'd, but now is everyone still in their home directory? We're good. Okay. Just for kicks, let's all go cd ... and then do a pwd. And you'll see that now I'm in my users directory for me. You'll see where you entered from you are. If you ls'd that, you see there's a whole different set of files. These are all of the users that have accounts on my computer, right? Your list is going to look different. Why does Alan have a user on my account on my computer? I'll just remove that. Okay, I'm going to CD back down. I could either do this. Now, I could go CD C Stahmer, right? Or I could do CD what? Tilde, exactly, right? Either one of those will get me back to my home directory. And then I'll just PWD it, not OWD it. Now, some of you may have noticed that I don't really have to be PWDing all the time, because you'll see that my command prompt is changing. It's actually showing me where I am in the command prompt. But if you start getting really deep in a file system, this starts to break down. And so it's easier just to like PWD, copy, paste, and then paste that into your code and get it that way. Everybody with me? Yeah. So in a weird way, there's not actually a utility for it showing up. There's a real utility for it being there. The way file systems actually work, it actually exists as a file reference in the directory system. The reason in Unix we call them directories, not folders, is because the way your computer really stores things, there is no single file. There's a directory of bits of information, their locations on physical drive or flash memory or wherever, and a directory that says, here's a file, it lives here, it consists of this bit, then this bit, then this bit, then this bit, then this bit. That's actually what's going on in your computer. And so the way Unix handles that is in every time you create a new directory, it automatically creates those file references so that they're there. And they're very useful when you're coding. Because there's a lot of times when you're in like loop situations where it's great just like go up 3 directories. Then you just go cd .. dash .. slash .. slash. You know what I mean? And I don't care what it's called. I just know that my whole application is set up with this directory structure, right? So does that answer your question? Yeah. Okay. All right. So everyone's back in their home directory and we're good to go. Okay. So the next thing we're going to do is we're going to actually make a new directory, right? And the command for that is mkdir, not dir, short for make directory, mkdir. And let's just everybody call it, hopefully I don't already have one of these, DataLab. Then you'll remember you were here and it'll be easy for you to do with what you will when we're done with this workshop. And hit return. Okay. Now, here's another thing. In Unix, if you see nothing, if the computer tells you nothing, that means it worked. It is not, Unix does not like to talk. It is not designed to be a verbose system. Why? because when you start doing large scale computation, all that verbosity is just a waste of time and effort, right? It's unnecessary computational time, and it doesn't matter. So it talks to you most often when there's something wrong, right? But if you just hit it and it looks like nothing happened, that's actually telling you it worked, something good happened, right? And I'm there. So if we ls again, you'll see in our list somewhere in here, I will have, there's mine, and in yours, you'll see a DataLab directory, right? That you now have created. And if you click over to, I'll click over to my Finder, and I go to see Stahmer, and there it is, DataLab, right? It's now also shown up in my Windows Finder system. I'm having you guys click back and forth like this because it, just so you get used to recognizing that you're actually looking at the same thing two different ways. It's two worlds into the same universe. But you will also find if you do a lot of coding and a lot of this kind of thing, I just move back and forth all the time between my terminal and my Finder. There's some things that the Finder is just really efficient and really good at, and there's other things that it sucks at. Other things that the terminal is just really good at and really efficient at. And so I almost always just live in a world where I have those two things open and very frequently sync to the same place so that I can perform different kind of tasks that are most efficient in that universe. Right now, I'll click on my Finder. You can see, as expected, there's nothing in there. But again, if I went in ls-a, what's happening? My computer's freaking out. That's the first time I've ever seen that happen. I don't think I've ever had terminal fire an error on this computer, on my Mac. I know, of course. Semper Gumby, man. That's what we do. All right, CD, boom. CD, or I'll just do the whole file. I could go like this, boom, DataLab. That gets me back there. Oop, I said you can't, you have to spell it correctly. System is picky about that. ls, there we go. ls-a. And you'll see that the only things in there are my, oh, you know what? I think it was actually the view. I think it's because I was so zoomed in. I think it actually was showing up somewhere else. Let me zoom this back up though so that you guys can see better. So here's your thing. You can see as soon as I created the directory, I automatically created file references for itself and for the parent, but there's nothing in it, okay? Let's do, I won't do rm yet. Head, let's do this. Does everybody have some kind of file, text file in their home directory or somewhere where you know where you can get to it? Yep, okay. We'll do, so I'm gonna go back up to CD, back to my home directory. I'm gonna do an ls. I'm gonna see that I have this ballad_authorship R file, right? You can do things like this. You can do head ballad_. Now I'm going to show. I'm actually going to just show you this trick because I was tired of typing myself. Let me try to move this up. Oh, come on. There we go. Come on, Doc. There we go. Okay, can everybody see that bottom line? If anytime I'm on a directory in my Unix system, if I start typing a file name, as soon as it becomes unique, where there's no other file in that directory that could match that string of characters, if I hit tab, Unix will just automatically fill in the rest of the name for me. This is a wonderful piece of shorthand that will save you a tremendous amount of time. Frequently, you only have to type 1 or 2 characters. You just go boom, tab, the name shows up and you're there. The head command will just show me the top 10 lines, I think, is by the default of that file into my window. So I can just look at the very beginning of it. I can look at the very end by saying tail, and you guys can play. What was it? Ballad, authorship R. It will hit the tail of it. This will do interesting things like, let's say, I'm going to copy and paste that. But let's see if I went head.png, boom, You'll see it'll actually read just the binary. It'll read a binary content. It looks like gibberish because it's a binary file, right? But it's actually sometimes tremendously useful because you don't know what you're looking at and something's not working right. And you just look at it and you go, oh, well, that's why. It's actually not a text file after all. I thought this person gave me an ASCII file. It says .txt, but it turns out it's a Microsoft Word file or something else that just has the wrong extension on it, right? So it will let you look at things. That's much harder to do on your Windows system. Another very useful command, banner, hello. We'll draw a nice big banner. I'm so zoomed in, it doesn't work, but you can try that. There's lots of hidden little Easter egg commands that happen in Unix. Now, one thing that you need to know is, I'm not going to do it because I'm not stuck anywhere, but this will come up. But a command that is really important and useful to know is control, sorry, that's very loud, C. Okay, you hit your control key and then a C at the same time. We'll shorthand that, and most of the literature, most of the documentation will just look like *C for control C. This is kind of your universal get the hell out command in Unix, right? If you're in the middle of something and you hit something in your command line and you're suddenly looking at just like a screen and there's no command prompt anymore and you don't know what to do, control C is a really good default thing. It will usually skip you out and like get you back to a command prompt that looks like you know what you're doing. So just know that one. Sometimes just a Q will work too, but control C is your better default. Okay, so for right now, that's really all. Just being able to move around, CD around in your directory space is really all you need to be able to do and type commands at the command prompt to work with Git, right? You just have to get into directories and then you have to type Git commands, which is what we're going to roll into. The one other thing we're going to cover very quickly, though, is that VI text editor, just because, again, this might come up for you. And what VI is, again, it's a text editor, meaning, you know, for those people that aren't coders, most people are used to writing text in like word processors, Microsoft Word, or Office Libre or something like that, right? But when you write there, that's actually a very complex system, and it's saving, like a Microsoft Word file actually isn't even a file. It's actually a directory that has a whole slew of XML files inside of it and all that save all that information constructed, right? That doesn't, for those that code, know, for those that don't, that doesn't work well in like a coding environment. So once you move into like a data or a coding environment, we tend to get out of those programs and into things that just navigate more directly with what are the actual just characters that are in the file. And we use a thing called a text editor. There's all kinds. People use Note++, BBEdit, things like that. But there's ones that come native with most systems, and the one that Git by default will try to throw you to is this one called VI or Vim, right? And the reason I'm introducing this is because, again, if you make a mistake in certain places along the Git workflow, it will just automatically launch VI. And so if you've never seen it, you don't know what to do, and you will be totally stuck. These things are very powerful, powerful text editors, Emacs, VI. These Unix systems are awesome. We teach whole workshops just in those sometimes. I'm only going to just introduce it here so that you guys have seen it, opened it, know how to make a file, save it, that type of thing, so that we can be, so that you know what to do, right, if this goes bad. So what I want everyone to do, make sure, right, for right now, you're in your home directory, not in the DataLab directory. So everybody just do a CD tilde. And the command to launch VI, if you want to open a file, let's start with just create a new file. We want to just create a new file. Well, I'll just create a new file. You just type VI space and then the name of the file. Let's just say test1.txt. Hopefully you don't already have a test1 in your thing. If you do, it'll just open that file instead of writing a new one. As soon as I hit return, everyone should see something like this. Okay? Bunch of tildes down a side. It's telling me that I'm in a new file called test1.txt. If you happen to have a file called test1.txt in your home directory, you would see the contents of that file in here instead of new. Is anybody in that situation? Because I don't want to kill a file that's important to you. No? Okay. So now, to use VI, it's totally just, there is no point and click. There's type things, right? The first thing you need to do, right now I'm just looking at a file. The first thing you need to do to be able to type into a file is just type the letter I, which means insert. if I just hit the letter I, you can see I actually accidentally hit I and O. It turned to insert mode. So everybody hit I, you should see insert mode down there. We all good? Okay. Then I'm just going to type, this is my sentence, whatever you want to put in there. No one else can see your screen. Be creative. Sentence, right? Done. You can just type at will as if you were in any text editor, right? Basic typing works. Now, what we want to do is we want to save this file, and then we want to quit VI, right? Like many things in Git too, you'll see there are often more steps involved in a process when you're under the hood than when you are working through Windows system. But though that increased complexity gives us more control, right? For things why we do it. But in this case, really you do this, it just seems easier in a Windows system. What you have to do to get you need to get a command prompt, because you need VI to understand the difference between I'm typing in you and I'm trying to tell you to do something, right? Because there is no file menu bar to work on. The way you do that is you hit your escape key. You hit escape. As soon as I hit escape, you can see insert mode went away down there. Everyone should do that. And the next thing we're going to do is type a colon. So shift and then my colon key, right? And when I do that, a colon is going to appear down here. Is everybody able to get to that? That's telling you now it's in command prompt mode. Whatever you type, it's going to interpret as a command and not as text that it should add to the file. And the first thing we need to do is we want to tell it to write the file, save it to disk, and that's just a W return. Boom. And it's telling me it wrote test1.txt. It's a new file, 1 line, 21 characters written, done deal, right? Is everybody able to do that successfully? Yep, okay. Then I want to get out of here. And to get out of here, I have to hit escape again. This is my sort of overdue. I hit escape. I hit my colon again. That gets me to my colon. And then I just do Q. And it dumps me out. So escape, colon, it's always escape, colon, to get to the command prompt. And then the command is quit, Q for quit, right? And it knocks me out. If I run an ls here, I'll be able to see my file, test1. If I go to my Finder, see Stahmer, I can go to test1. And here we'll see, this will open it with bbedit, which is my default text editor, or text edit. This is my sentence, right? I now have a file there called this is with my sentence in it, right? So you just created that file with that text editor. And that's the text editor you're going to use to make comments on your commits when you're in Git. And again, so that's why we introduced that. So, okay, so we'll flip back to our terminal now. And the one last Unixy thing that I want to introduce is the manual command. And this is where you get help and teaches you how to do anything. So I've been telling you, type like ls space -a, right? There's really like 35 flags you can put on an ls command, all of which show you different things. The way you learn Unix is you Google Unix command for, and it will tell you, okay, that is ls. And then you go to your terminal and you say man ls. And it will give you the manual item for the ls command. They are very structured. They all look the same. Tells you what it is. And then it lists all of the flags. It's a really good, useful manual. You know, everything you'd want to know about that command that you could possibly do. Unix is super deep, super powerful, but if you ever are lost and you're not sure how to do, this is your solution, right? And it will get you to what you're trying to accomplish.
What was, you typed in MAN?
MAN, just MAN. And then from here you can see also I've got my little, when I'm up here, I've got my colon saying there's more, that's telling me there's more down here. I'm at the end, and it's just a Q to get out of the manual. Q for quit again, right? You'll bounce back and forth in these command line worlds between Q for quit and exit. And it's, you know, it's not, so if you're somewhere and Q doesn't work, try exit. If neither of them work, Control C, you know, and get out of Dodge, right? And that will generally, you know, your hacker's approach will work. All right, you good?
Mine says command not found when I typed in. Yeah.
The Git, oh, the Windows people. Yeah, do it, yeah, but they don't have that either, but you're right, we should have done that. How hard is the PowerShell install? It just came with it? With what version of Windows are you guys on? Like Windows 10? Windows has come a long way. Try PowerShell. Try instead of Git Bash. Will Git, can you talk to Git with the one that out of the box? Does it show up in PowerShell now? Do you know? Okay. Okay. So don't bother going there now if you're not already there. But yeah, it's good to know. Okay. So there's another application called PowerShell. So you may end up with 2 terminal windows open in your Git land here if you want to use like manual and stuff like that. So it's called PowerShell. Yeah, man, and then that will work. Okay, that is good to know. Thank you. Okay, all right, so at this point, we are ready to start doing some actual Git stuff. All right, we went over that. So let's just cover really quick, finally, because this is where we're all really here. Some basics of Git. I'll clip over to the big view for a second. And just talk about what Git is actually doing, how it functions, how we engage, and then we're going to dive right in and just start managing files and actually doing stuff with it. So Git is a service. It's another software application that runs on your computer, right? You don't use it to code, to do any of the things you do. You still do everything that you do the way you do it with the application that you do it with now, right? None of that changes. Git sits beside that, and it engages the file system directly and does some things under the hood and behind the scenes when you give it commands related to the file structure and the files that are being created by these other things, right? Now, you will hear people say things like, well, Git's only good for certain kind of files. I stand tall and will wrestle anybody over this. Like, that is fundamentally untrue. You can put any kind of file into Git. You can manage anything that lives on your drive in Git, right? What happens is there's certain functions that won't work, like you can't diff Microsoft Word files. Well, guess what? You can't diff Microsoft Word files anywhere else either. You know, that just doesn't work, right? So, I mean, yes, there's not full functionality, doesn't apply to everything. It's getting better. We'll get to diff for those people who don't know what it is, but like there actually already is diff that you can get for CSVs, for binary files. So it's improving a lot actually in its ability. But you can basically do version control on any kind of file that you do. Like I version controlled my whole dissertation written in Microsoft Word, you know, in the 90s, right? Can't do all diffs and things like that with it, but it's still, rather than having 300 versions of a thing that say V1, V2, V3, and all those things that you do, it still works better. So you just keep doing your work as you do it. And what we're doing is introducing some command line workflow around that, right? That will help you manage the file. Another key thing to understand, you will hear of things like GitHub, GitLab, Bitbucket, right? These are cloud-based services that actually run the very same, literally exact same Git software that you just downloaded onto your computer is the software that runs GitHub, and the software that runs GitLab, and the software that runs Bitbucket, and all the other cloud-based Git systems. Now, what they do is they have a lot of apparatus built around that software that provide unique services, and that's how they try to compete with each other and see, you know, who wins your business, right? And don't kid yourself. As of several months ago, or maybe almost a year ago, these are all a business. Like GitHub still has this kind of reputation as the thing. Microsoft owns GitHub. You know, I mean, it's a business model. It's not, you know, it is no longer like a bastion of open sourceness that is there. As a member of this university, though, you can get it for free, right? So you can get private repositories. You can sign up through the UC Davis domain. Can undergrads do that, Pamela? I don't know. Yeah. So anybody here, you can still use it for free and pre-protected. These are cloud-based versions. We're not covering in this class how to engage with those cloud-based versions, right? What happens is it's a way of sort of syncing your local version to the cloud version, right? But they're really just doing the exact same thing that you're going to do right here in your local machine, but doing it on the web. And if you use these services, the way they work is you don't really work in them anyway. You still just do what you're going to do in your local, and then you tell it, send this up to my version on the web. The two versions of Git talk to each other. And if you take the for Teams, you know, class, you'll learn like it's very common in a production environment for not only am I talking to the cloud, but we're talking to our computers individually. You frequently have direct connections to Git on your laptop and yours and to the cloud, and we're just managing things, moving them all around all the time, right? So that's kind of how Git works. It's very distributed, but you're just going to run it locally for this class. A very high altitude view of what is going on, and then we're going to drill down from here. You're in your local computer on the file system. You have a file that lives in your file system just like you save it now at any time in any application. Git has a database, essentially, system. It's a flat file system, but it operates like a database that is connected. We call that putting it under version control, that is now tracking this area, and it stores versions of it over here in its database. And then depending on what version you want to look at or what you need, and we're going to do all this in this class, it will move a version out of this database into the file system. It'll actually do a replacement of what's already there with one from here and swap them in and out and move around. So it's taking control of the file system, but it actually lives in its own world, and we're going to see this in these hidden files that you can't normally see, right? Which is where it's actually doing all of its magic next door to Git. That's what's really happening with it. The more complex, truer version is that that database is multi-tiered, right? You have your working directory, and that's whatever directory is under Git control and that you're working on files in. Git actually maintains two things. It maintains a staging area, which is where when you're in Git, I put things and I'm telling it I'm going to want to save a version of this, right? And then it has the actual repository itself where you're saying, now we've saved that version, right? Now that a lot of people immediately ask, well, like, why? And you'll see, especially when you start working this, like, why do I have to like stage a thing and then I commit it? Why can't I just commit it? Does anybody who's done a little bit of Git want to hazard a guess for the logic behind this two-step process? In case I want to undo something, but even if I committed everything, I could still undo it. The real reason is because I might not want to commit every change that I've made, right? Let's say I'm working on something and I've actually worked on 4 different files in my working directory, right? 3 of them are now working perfect. And I'm like, I want to save that. But the 4th one is still a mess, right? But I actually want to save a version that captures those 3 that are good. I can stage those. And then when I commit, I'm only committing the ones that I care about, right? It allows you that kind of flexibility to say, of all the things I've changed, I only want to commit these 6 things, not all 26 or whatever. And this is a real common problem for people. If you work with a lot of data and a lot of code, you're very frequently bouncing around between files as part of the same project, right? So that's why the 2-stage process. But it's important to know that 2 stages there, because as we turn into Git, which we're going to do pretty much immediately now, the process is always, I work on a file in my working directory, I stage it for commit, then I commit. If you forget that and try to work outside of that, Git will actually yell at you, but then it won't work, right? So you have to just remember it's always that double tap that you have to do. The other thing to think about now, and this gets down to the workflows, is that there's a difference between saving and committing, right? So let's say I have this file, I'm looking at a single file in my working directory. I'm working in my text editor, and I say milk, eggs, and bread, and I save it, right? I have to tell Git, I want to commit that version. I want a snapshot of that version of the file, and I want to save that, right? But I could keep working and add soup and hit save, right? Well, that's saved, but it's not committed. Git hasn't done anything with that. And then I go, no, I want to rip bread out, and I make all these changes. Then I get to my 4th save, and now I say, that's a version I want to capture. I want to save that version. And there's all kinds of reasons why we choose. I think this is stable, or it's just gotten to this point, and I know I'm going to make a major left turn, but I don't know if that left turn is going to be correct, and I want to be able to roll back to this version, right? In case all of this other thing I'm going to try is totally wrong, rather than having to try to remember what I wrote and delete it. So you have to, don't confuse saving with staging and committing, with the commit process, right? Committing is a conscious decision in the Git universe that is not happening automatically. And so you have to decide, what does that mean? Am I going to commit every time I save? I can tell you pretty much that's probably overkill, right? You have to have some decision-making processes. This version of it is important enough that I want to be able to get back to it. That is your deciding criteria. And you may want to get back to it for several different reasons. You may want to get back to it because you think it is a stable version and I want to save that. You may want to get back to it, as I said before, because you're about to try something radically new and you're going to add a whole bunch of stuff to it that may just be totally wrong. And it's not until you've done it though and tested it that you know it's wrong, and then you go, okay, that was worthless, I'm out. Roll back, and then you just throw it away. And just typing one command, right? 2 commands really. So there's various reasons. If you get into software development, there's a testing version, and then I want to canonize an actual deployment version. So you have to think about your context and what makes sense for you to save. But I will say, while it's overkill to save, like to commit with every save, generally speaking, people do not commit enough. It's not that hard to do. And the sort of rule of thumb, and I'll harp on this a little bit more too when we actually dive into Git, is you commit often and comment verbosely. Whereas Unix doesn't like to talk to you unless there's a problem. You should comment every commit with some real detail, and you'll see why in a second, that says what that commit is. Because that makes your life that much better when you start going back and looking at versions and going, well, which version do I want? If everyone just says, yeah, saved it again, or change this, okay, now I have to go look at every one, right? So when I'm coding, I really make my commits, I actually say, I changed this function on this line. Even though I could easily figure that out, it's just so much faster for me to read my log and figure out what is it that I want to see. And when we get into the log files, you guys will see that. So as you're working through this, pay attention to that and know that you do that. So again, just to reiterate before we finally then really dive in, I think that's where we're going. Yep, we're about to actually start getting. You work in your working directory, you save things, you stage the things you want to commit, and then you commit. That's always the process, right? Stage, commit, stage, commit. Luckily, Git is very verbose and it likes to talk to you. And so almost every time you'll see as we get in there, it'll tell you exactly what your options are and what you should want to do. It wants you to do well. So it's pretty easy to use in that way. All right. Just very quick, you do not have to write any of this down right now, but just to give you an idea of what we are going to cover right now, that we're all going to code, and we'll just get into them as we code them. We're going to learn how to initialize the directory and put some files under Git control. We're going to learn how to check the status of our Git directory, of our repository, and see what's going on, what's the status that's going on. We're going to learn how to add things into the staging area so that they're ready to commit. We're going to learn how to commit things. We're going to learn how to check our Git logs and look at different versions. We're going to learn how to diff them, how to compare versions of files once we're there. We're going to learn how to throw away some changes, like when we totally screw up and we just go, okay, that was bad. I just need to go back to that, right? And roll back. And then we're going to learn how to look at and check out earlier versions, just because I want to just look at it, check it out, see what did I do in that version after all. Maybe I don't want to actually run file diffs. I just want to go in and look. So we'll do that. And then once we've done all that, we're going to cover some branching and merging, which is a whole nother aspect of Git. Yeah. That's a really, really good question. I actually do that in many cases and have no problem with that. In most cases, it will actually save your Git directory and it will work just fine, to do that. So I don't think there's any problem with that. And what you're really doing is giving yourself just double backup, right? I mean, you can sort of work in their universe, but then you could also attack it, from the Git end. So yeah, I think that's.
So then the native Git repository on your computer is going to be outside of the Dropbox folder?
It is and it isn't, which you'll see in a second. It will actually live in the Dropbox folder. But Dropbox actually has a way it knows that that was mine and not theirs. And so it does some things in its storage process that protect from overwrite and that type of thing, right? So it will still work. because all of Git's data actually lives in the working directory in hidden files, which we'll see once in a second when we all create one to get in there. But yeah, you can do that. Other questions before we dive in? Yep. Yes, so let's say whatever problem I'm solving means that I have to change. I'm working on 3 different files simultaneously to try to solve one same particular problem. This happens really frequently when people work with a lot of data, because I have data files, I have code files that I'm working on and I'm running on. So, and that will be distributed. Whereas if you're like writing a paper, there's usually one file, right? But even there, I could have appendices or things like that, right? So I'm working away on multiple files. And then I decide let's say I'm working on 3 of them. I get 2 of them to a point where I say, okay, these 2 of those 3, I know that part's good and they work and that's what I want. And so I actually want to make a commit right now to make sure that that's protected and preserved, but I don't want this other one that's not done yet to be part of that. So staging is really just a fancy way of saying I'm telling Git, only commit these 2 when I run my commit. Don't worry about the other one, right? Once they get into, there are some other things if you really become like a Git super user, there's some other ways because of how Git manages things where it can protect files. To put like a version in there from that, because once I've staged something, I could actually keep working on it before I commit it. And now I have a version, I have several versions. I have all the previously committed versions of that file. I have the version as it is in my working file, and I have the version that I previously staged but haven't yet committed. And some people actually use that as part of their workflow. It's like quick cheats. Let me just try something really quick over here. Now just throw away that one, go back to staging version, go back. And it, because they don't want to go all the way to a commit, but they do want to save temporarily something while they still work on that thing. Does that make sense? And move back out. Yeah.
Is that a strategy to prevent others from seeing your bad code? Like,
what?
You don't want to commit it, you don't be creepy about what you commit. It's like, since you're doing it as an open science practice.
I guess it could be, because people can't see your staging area, I mean, when you're sharing stuff. So yeah, you could do that. But to be totally honest, my recommendation is that you like just get over that. We all write crappy code. Here's news, except for the computer science class you were in or whatever class you had where it was in a textbook and it was perfect. Code is always bad in the beginning, right? Because it doesn't make sense to spend the time to make something perfectly optimized and the most efficient it can be and like just textbook perfect if you don't even know if the general approach is going to produce the results you're looking for. That's actually a total waste of time. So like anybody that produces perfect code day one for me, I'm like, you just wasted 50 person hours or whatever, I mean, like doing that, like get something and you see if it works. And then if the result is what we want, then you optimize and you make it good, right? So I don't think you ever have to defend your poor code. And the only people that ever call you out on that, and I swear to God, this is true. Anytime I hear someone like take something off and they start criticizing their code, I just go, yeah, that's like, first year PhD student in computer science, or, what I mean? Like, because once you've been doing it for a long time, you start to figure out, why. You start to understand why it's messy and why it's there. So just don't even worry about it. Commit your code and be happy with it. But do be committed to fixing it and optimizing once you go to production.
I'll also say that once you become more comfortable using Git, there are some fancier ways that you can
That's true.
Reset.
Yeah.
So you can make it so that it adds certain commits and delete them.
Yeah, and you can checkpoint and snapshot and there's yeah.
Like if you're going to production or something,
Yeah.
You might just fork a copy. We'll talk about that next.
Yeah.
That also takes some of it.
It's true.
This pressure. So you can clean up your
You can, yeah. But
on.
you should just stand by your messy code. I'm going to advocate for that. This is being recorded. I'm advocating. I'm not advocating for poor coding, really. I'm advocating for the approach to coding that is actually more optimized as an approach than writing perfect code from the get-go. I'm sure I'll hear about that. Okay, so without further ado, let's go ahead and have everybody, let me click out of here. And again, it's just taking forever. let's have everybody get back to your Git Bash or your terminal window. And then let's CD to that DataLab directory that we created. So your home directory, DataLab. And just so I don't forget what it is that I want to cover. Okay. So right now, everyone should be able to ls and see that that directory is empty. We haven't done anything in it. So the first thing we're going to do is we're going to take this directory in anticipation of the fact that we are about to change the universe with our incredible work and research, whatever it is that we do. And this is the directory in which we are going to do that, right? So we are going to put it under Git control right out of the gates before there's anything there. You can run the same command. You can take a directory that is totally already populated with 1,000 files and just run this same command and put it under Git control. It does not have to be a blank directory, but we have one, and so that's where we're going to start. And that is just git init. Git space init, short for git initialize. And that's saying we initialize that directory and put it under Git control. And you will get a message that looks something like this: initialized empty Git repository in, and it's telling me where it is. And notice it's my DataLab directory, and then I've got a .git folder after that, right? That's actually where, in my working directory, all of the Git database and everything lives. The really cool thing about the fact that it stores everything in the directory itself is that you could drag and move Git directories all around anywhere on your system, and they still just work perfectly, right? It's not like you have to go in and now reconfigure some global Git to say, oh, this is where that repository is. The repository is wherever the directory is. It's immensely flexible and really, really nice compared to others more top-down driven systems. So now, if we run ls, was everybody able to successfully init? We're good. If you run ls, you'll still see nothing. But if we run our beautiful ls-a, we will see that there's now our Git directory with our database set up, ready to go. Let's just do a quick cd into, or for those, I'm going to introduce a oft forgot and almost never used anymore Unix command that's secretly there. Maybe it'll work on Git Bash. pushd, short for push to Git. This maintains a directory stack. It lets you navigate, pushed and popped, which is what I'll do to get back out. Lets you walk through a tree, and then you can pop your way back up that tree. You don't have to remember where you went. You can just walk around rather than CDing all the time. But you could CD into it too. I'm in that directory. And now if we ls in our Git directory, you can see all the files that Git has put in place in order to manage the database itself, right? The head, just so people know, the head is a reference to the current latest working version of the file. Your latest commit is your head. So it's always storing that there. We'll get to what branches are, but here's your other objects and references to them. And I'm not going to go into the whole thing, you don't need to know. But a config file, which I invite you to look at some point, and it tells you cool things about what your Git does. But this is where Git does its magic itself. You will pretty much probably never actually need to go in here unless you really start to become a super user and you want to come in and toy with the config, or secretly, for some unknown reason, come in and start actually pulling binary data out of the head or that type of thing. So I just show it so you know it's there. So let's all CD, like I could do now because I did pushed, I can do popped. And that'll just takes me back up to my DataLab directory. But you guys, if you didn't push in, you can go CD, boom, DataLab again, right? And that will get you there. And what we're going to do is the first thing we're going to run is a Git status. We have this empty directory. We're going to get Git to tell us what is the status of this directory. Git status is one of your most useful Git commands of all time. I use it all the time. I overuse it because I'm obsessive compulsive, and I'm always afraid that I'm going to do something when I shouldn't. So I check the status before I execute every single Git command. I just sort of can't stop myself because I want to make sure I know where I am. You don't have to be as insane as I am, but you'll see me do it because it's forced to have it. But it's just a good thing to do. But we'll all do it now, so we do it. If I go Git status at this point, it's telling me that I'm on branch master. For right now, I don't want you to worry about branching. We're going to cover that next, okay? But you'll all be on branch master right now by default, and there's no commits yet. There's nothing happened in here. I get this nice summary. Okay, everyone should see that kind of thing. If you don't, put up a pink sticky so we know something's wrong and someone can come try to help you. All right, we are looking good. I like it. Okay, now let's create a file and put it in our directory so that we have something we can start to play with with Git, right? So we'll do VI. Let's go VI my file. And it's just easier for this if everyone uses the same. Otherwise, if you name it something different, you're gonna have to remember that for the rest of this exercise. So if I go VI myfile.text, it's gonna create a new myfile text, new file. I'm gonna do an insert again. So I to insert, to get an insert mode. This is my file. If I could only type. Geez, Carl, come on. It's called my file. It has 1 line and 3 sentences. Arbitrary, you can type whatever you want to type, right? So this is my file I created. Now I'm gonna, who can tell me what I do to write this to disk? What's the series of commands? Escape first, and then escape, but then you're there. :W. It wrote it, 1 line, 76 characters written, we're good to go. How do I quit? Escape, :Q, exactly, there we go. Escape, :Q, we're out. If I ls, you can see that now my file exists there, right? So I've created that file, and now remember, I did this totally outside of Git. I could have created that with any application and created a file and put it there. Git doesn't care, you just work as you would normally work. But if I do come in my command line now and I say Git Status again, you can see that it's still telling me there are no commits yet and that there's an untracked file. Okay, there's this file there that Git hasn't done anything with. It's not saving it, not tracking it, and it's myfile.txt. You guys should all see that. And then here's where I said Git likes to talk to you. It's telling you exactly what you would need to do next to make a next most logical move in Git, which is to stage it so I could commit it, right? Which is use git add file. Inside the caret means the file, name of the file, to include in what will be committed, right? Doesn't use the word stage, but that's what it's telling you. To stage it for what will be committed, you just type that. And so all you have to do is literally do what it says. Git add myfile.txt, right? Hit return. Now again, because we're in Unix land, it looks like nothing happened. It tells me nothing happened because it doesn't want to waste my time, right? But if I go Git Status again, now Git Status has changed. I still have no commits in my repository, but changes to be committed now is my new file, myfile.txt. Everybody see that? Okay, so we're going to put this file now under version control. We're going to commit it, and that's going to be our first major step, right? So to commit, we'll do it the longhand way first. We just type git commit. You don't have to tell it what to commit because by default, it commits whatever has been staged to commit, right? That's the way it works. If we type git commit, and here's where this should start to look familiar. What it's done is it has loaded VI. It has launched VI, and it's given you some comments. For those people at code will recognize this. These are comments, meaning that stuff that will actually get ignored. It's just there for your information. And it's telling you, enter a commit message for your changes. Line starting with that, the number sign, will be ignored. So none of these are going to show up in the commit ultimately. And it's just telling me who I am, boom, boom, boom. Notice it knows like how I'm logged in, which branch I'm on, and it's saying this is the initial commit. Otherwise it would give me a commit number. And it's telling me what it's going to do, and I only have 1 file. That's what I expect. So I can look at that and go, all right, gold, this is good. So I'm going to hit, because I want to comment verbosely, I'm going to hit I, because I'm in VI to insert. And because these things are going to be ignored, I don't have to like move down below them. I can just typing my comment up above them. And I'm going to say, like, committing, I don't know if that's spelled right, but first version of repo with single file, 1 line and 3 sentences. So pretty descriptive of what's there, okay? You can say whatever you want, but you notice this is indicative of the kind of, I want something that really describes what's in the commit, right? Once I have it, I just do my normal thing, escape, :write, to write it, escape, :quit. And Git gives me a nice message that one file was changed with one insertion because there was just a single line in that file that was inserted. Create mode 100.644. I'm not going to get into these codes. You can look them up if you want, but it's all good. It's meaning it actually had to create it because it was a brand new file as opposed to writing in another file. And then this was the file. If there had been many files that had been staged, it would give me one of these lines. It was, say, like, 7 files with 23 insertions, and then I'd get 7 lines telling me what was going on with each of the files. Everybody follow that? Okay. So now we'll go Git status again just to see what it looks like. And Git is telling me once again, there's nothing to commit and the working tree is clean because I haven't done anything to change that file, right? So once I've committed it, Git resets itself to that head state. It's saying, okay, what is in the working directory looks exactly like what is in that commit. So nothing to do here. Does that make sense to everybody? It's already automatically comparing the working directory to the last commit, which is that head commit, okay? Now, we'll use this a lot, but let's just look at it once now. If you go git space log, this will give you, and this will start to grow as we work today. I only have one commit. This will give me a log, Git log starts here, of all of my commits. Each one will be a 3-line. You'll see when we get multiples, but it's telling me, okay, I have a commit. This is crucial. This is the hash for that commit. It is a computationally unique ID, a hash. People know what that is. It is a legitimate hash for that commit that will uniquely identify that commit from every other commit in the system forever, right? Even if you were to delete, which you can do, delete commits, no other one will ever get this again because it's a legitimate file hash, right? So it uniquely identifies that commit. It's telling me that that commit is currently the head of the master branch. And again, don't worry too much about branch, but because we'll get to that yet. But the head, meaning this is the latest version, right? That's there. It's telling me who the author was, which when you're only working locally, doesn't matter that much because you are, you get that? Another pink? Because it's always going to be you. But now imagine in a team environment where you have multiple people committing to a same repo, that line gets really useful and the date and time that it happened. Okay, some basic information about it, which is really, really good to have. Now, following that, what is this? People recognize that from my type in? That's my comment to the commit, right? So I can see what is this commit about. I was committing the first version of the repo with a single file, 1 line and 3 sentences. Okay, that's my commit. Then I'm done because I only have the one version. Okay, let's wait a second and see who we have some stucks.
So it doesn't tell you what the file is.
Not at this level. No. When we look at it, you have to look into it, which we're going to do in a minute, and then you can see what's actually in it. And then we can even, we'll do diff too, where it'll show you the actual differences that are there and that type of thing.
Another thing I was having issue with was I was copying the file directories or file paths from like Windows Explorer directly in.
And it's not working.
It doesn't recognize
The Git Bash wants them to be the other, or
but like, I don't know, there's some syntax issue where like sometimes it's okay with some, I always get the back and forth, like it's like you want the backslash.
it's C:// and then backslash after that. C:// and then it should be backslash after that on Windows. Yeah, is full. Yeah. Okay, are we good? Okay, we'll wait just a second. Do I have any other questions? We have a few more people that are working. Pamela, you see another pink 1 minute while we work out the few problems. Any other questions? No? Okay, I'll wait just a second. Okay, I saw that one went blue. All right, I think we're good to keep moving, so we'll move on. So now, let's do this. Let's change that file, right? And then we'll commit that change, and then we can start to see what it looks like when we're actually dealing with changes. So to change the file, I'll just use VI again. myfile.txt was the name of the file. So now you can see I'm back in the file. If I want to make changes, I have to hit I again to get into insert mode so I can get into the file. And now I'm going to change this, and I'm going to say, this is my file. It's called my file. I'm going to break this down to another line. Let's do this. Here is another sentence. And then I'll say, oop. The file has now 1, 2, 3, 4, 5 lines, because I'm counting blank lines as a line, because the computer does. 5 lines and 1, 2, 3, 4 sentences, because I'm including this sentence. Okay. So I've now adapted my file. I've made some changes to the file, and I'm deciding I want to now save this, right? So I'm going to save it. Escape colon write. Escape colon quit back out. So that's now saved. Now keep in mind it's saved, but it's not committed. It's nothing. I could open it up, change it again, work on it some more. Git doesn't care, right? But now let's say that version I actually do want to commit. What we're going to do, let's just do a git status to look at it again and see our status. Oops, there we go. Okay, it's telling me, now I get a little bit of a new message because it's not a new file this time. I've changed it, right? It's telling me to add git file. I've modified my file.txt. I have 2 choices here. I can add it to update what will be committed, or if I decide what I did was just junk and I just want to throw it away, I can just do git checkout -- and then the name of the file, and that will pull the version from the head from the last commit and overwrite my changes, right? So you could just totally revert to the previous version at this point, and that may actually be faster than going in the file and trying to delete whole sections, right? So sometimes actually popping into Git and telling it, just throw it away and put the head back in place with that is faster than you could throw the changes away yourself in the word processor or Excel or whatever you're working in, right? You just have to decide. These are our choices, but for our purposes, let's go ahead and just stage that. So we're deciding we want to save this as another commit version. So to stage it, we're going to follow directions, right? Which is git add. And one thing you should know, one function that this add command will take wildcards. You can do git like that, and it will just automatically add. So if you had like 300 file names here, you know, it would just put them all in the staging, right? If you just say, I want to just stage every single thing I change, you do git add. We're not going to cover it here, but I will caution you a little bit on using the wildcard. There's a thing called git ignore. We'll get into that in the next workshop, but where you can tell it to ignore certain files by default. Very useful for team science because everyone has hidden files in every directory of your system that your Finder, that your that Mac operating system or the Windows operating system use to let Windows Explorer or the Finder work. And if you start committing those, when you hit the wildcard, it's going to put all those hidden files in there too. And now the whole repository gets messy because those are always going to be different from every person to every person. And so it just gets to be a nightmare. So I don't generally recommend using a wildcard until you become really git ignore proficient, but it will do it. myfile.txt, we'll add it. We'll check our status. And now just what we expected. It's again telling us like we have this one ready to go. It's changes to be committed, our new file. Everyone with me so far? We good? We good? Yep.
It says you can use git add or commit -a. What's the difference? Is there a difference? Where it says no changes added to commit, and it says you can use add.
Right here?
That way.
Oh,
Yeah. And then you can use add.
that's the same as a wildcard. Like I could just commit all, right? You know what I mean? But I'm not, if you do this, it will actually stage and commit simultaneously. I'm kind of purposely not doing that right now because I want you guys to get used to the to doing it in pieces. But there are all these shortcuts that you get to. Same thing actually with VI. There's another command that would just let it write and quit simultaneously. So, but you have to earn your way to super user. If you go straight there, then you forget that there's the stage and that, and we will end up in trouble eventually. Yeah. Okay. So let's go ahead and commit. Now I am going to show you another shorthand for the commit now. I can skip going into VI on my commit with this git commit -m for message, single quote or apostrophe, however you want to refer to it, added a new sentence and broke into multiple lines. Okay, this works. Where people always get in trouble is people start typing verbose comments and they'll put an apostrophe in the sentence of their comment, and that confuses the whole thing. And that's where you will accidentally end up in VI limbo, and you have to go to your insert and navigate around. And you may end up actually in a Control-C situation where the whole thing like aborts and goes bad. And then you'll have to do your git reset head, which we'll do at the very, very end. So be careful with this. Really be conscious if you're going to use this shorthand that you do not include any apostrophes in the comment itself or it'll die. But if we do that, it just bypasses. I don't have to go into VI and do all that. It puts my commit on. And we get that it was there. My name and email were configured automatically while I'm getting this. That's fine. I can go ahead and change that. But I'm now committed 1 file, changed, 5 insertions, and 1 deletion. Okay, and that's actually true. That deletion was because I deleted it from 1 line, the 1 sentence, I moved it down 2 lines. So that counts in Git land, that counts as a deletion and then a reinsertion. There is no move, right? So it's just giving you an idea what happened. Let's run a Git log. And in Git log, we now see that we have 2 commits in play, right? Our first one where we added, and it's in reverse order. So the very first commit committed the first version of the repo, but then the newest one is always on top. I added a new sentence and broke into multiple lines. I see my comment. When you start to see the log and you start to think about how many times you change files and want to save versions of them, now you start to see how valuable verbose commenting is, right? If these comments are not descriptive of what you actually did, you know, saving because I wanted to go to dinner, you know, you just lost all of the description of that save, and I guarantee in like 3 weeks, you're gonna come back and wanna jump back and look 3 commits back, and you're not gonna remember that those changes happened in the file that you committed because you were going to dinner, right? You know, so be descriptive so that you can read through these and they make sense to you. Okay, everybody good so far? We see how that works. Okay, so now we'll deal with where now things start to get a little more interesting. Let's modify the file one more time. Let's go vi one more time, myfile.txt. And I'll run an I for insert. And I will do this. I like this one. So now there are 5 sentences, escape, write, escape, colon, quit, boom, okay. So now if I run my Git status, once you get through that, I can see, which I expect, that I've modified this file. Now let's say that I want to see the differences between this file here, right, and the earlier versions of that file. Right? This is one of the powerful things that we can do. What we do is I look at my log, and let's compare it to the earliest, the very first version of the file. I take the hash from the oldest version of the file, which is the unique ID for that commit, and I've just highlighted it, and I'm just going to copy it into my clipboard. And then back down on my command line, I'm going to type this, git diff, followed by the commit that I want to compare to, and then the file that I want to compare. Okay? This is going to automatically compare the working version, the current version, with the version in that commit. Does everyone understand what's going on? When I run that, I get this result, which I'll help you learn to decode. Okay? What this is telling me is that the first file has had one deletion compared to everything else, and the second one has an insertion 5 times on 5 different lines, right? Because I added blank spaces to count, and it ended up being a 5-line file, right? Whereas the first time it was just a single line file. So you don't get the comma space because it's only on the one thing. That's the difference between these two, and you can see them spelled out. So in the first one, the very first file, this version, the first line read, "This is my file. It's called my file." It has 1 line and 3 sentences, right? And the version that I'm in the new file, the latest version of the file, it looks like this is my file. It's called my file. And the difference is that I deleted one deletion from there, right? And then on my latest version of the file, I also added a second line, another blank line, boom, 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 right? So it's letting you see the differences between these two files, right? A lot of times, just this line is all you need to see. Like sometimes you're just looking for where is the breakpoint where I made a major change in this function, right? And all I need to know is just like, this one is way bigger, right? This is the one that has 300 deletions there. You can also run your diff on the entire repo. And it'll give you this for every single file. Boom, 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 all the way down, right? But so this is a very, very, very useful thing. Now let's say you have diffed and you've decided, I actually don't want to look at that file, right? And see it. And here's where Git starts to get really interesting. So whether I'm in command line or if I'm in, I'll just go to my directory here again and look at it this way because this kind of shows the point even more. What is it? DataLab was the name of the directory. Okay, here's what this file looks like right now in that directory, right? Looked at in a text editor. Let's say I want to check out that, that version because I really want to look at the contents of the file itself. The command is git checkout and then that commit number. Okay, I've got git checkout that commit number. I'm going to run that. Oh, okay, see, I forgot where I was. This is a really good thing. It doesn't want me to check out the new version because I have unchanged. It's telling me you're going to lose the work that you've done. You have an untracked file, right? Because I made a change to that and I didn't commit the last change from my working directory, right? And so Git protected me from myself. The following would be overwritten. Commit your changes or stash them before you switch branches, aborting, right? So it's telling me at least stash it. I don't necessarily have to all the way commit it, but I'm going to go ahead and just do, let's just get it in there and get it git add my file txt and then git commit -m, added another line and another sentence. I think this is what I did on line 2, line 3. Pretty sure that's what I did. In the real world, I'd be sure about that. But okay, that's there. Now I can do my git checkout and it doesn't care about the overwrite because I can recover that file. Git checkout, and there was my commit number, boom, okay? When I check that out, it's telling me the head is now at that commit, and this is the comment from the commit that just got reverted to head. So now if I go to my file system, or I could do it in VI here or head or any version, you can see that it looks the same. It's just the my file there, but it's actually that version of the file from that commit, right? So Git has swapped out from the working directory the latest version with the version from that commit. So I can look at it, see it. I may copy part of it and then throw it, you know what I mean? Say I'm going to copy and paste this, then I'm going to go back to the old version and paste it in, whatever. But that's how you look at it. To get back to your original, what you want to do is you want to say git checkout. Let's just master. Let's just go with the branch that we're on. That will automatically take the head. And everybody here, like I said, is the default master. In a second here, with the 5 minutes left, we're going to talk about branching. And that will get it back to the head version of whatever was there, right? And that just sort of restores the state. Everybody with me? Okay, real quick, we got 5.5 minutes. This was the last topic that we were going to cover today, was a thing called branching. So we've always been on this default master branch, right? But Git supports this thing called branching, which you probably won't use that much right now, but I'm just going to introduce it here. It's crucial in working Git for teams. And it can be useful in some context. I use it locally just because I'm used to it and it's kind of what I do. But so this is just a brief introduction to the branching problem. Let's see, where's my PowerPoint? PowerPoint. Okay, branching works like this. you have your working directory that you're working on, right? And we've been on this thing called branch master. And effectively, let's just assume on this side of the board that we have two versions of the file that we've created, that we've committed, right? Now I want to make some changes, but I don't want them to affect the main versions of this file. I'm not sure that they're really going to take, that it's what I really want to do forever. In a team science world, it's because I don't want to work on the same file as somebody else. I'm working on a particular feature. So we typically use what we call topic branches, feature branches, where I'll pull this out to a new branch. What that does is it literally branches off. It creates another version, duplicate. The first version of the new branch is a duplicate copy of exactly what it looked like on that branch, right? And then I start running commits on that branch. And those commits do not affect this master at all. So in the meantime, I could go back to the original master branch. Those don't even exist. They're totally invisible. They won't be on my file system. They're not there. I go back and now they're there. This is really useful for like debugging, stuff where you're working with code especially, where you want to be able to run the thing and have it working in its working state, like it's in production. But I'm trying to actually test some new functionality over here to the side. It lets me go, okay, check out that branch, do my development over here, but now I actually need to run the process as it currently is because the lab needs those results. I check the master back out, I run it, everything's copacetic, I get results. Now I want to go back to making my changes. I go check out the other branch, right? And those don't affect each other. Does that make sense to everybody? So it's a way of further segmenting code into these branches. Again, that's the only really scenario where I think it's useful individually. Effectively, you still have a whole line that's a single branch because we have this thing called merging, where we merge the branches back together. You get to where you say, okay, I'm now satisfied that this is good, and I want to make it the definitive master version. We run this command called a merge command, which will put the two things back together. We've got 2 minutes, but you could very quickly, we get halfway through an example, it'll take 2 minutes for this thing to get away. And I'll just walk you through it quickly. You can try to follow, and if you want to, but I'm going to move pretty quickly just so we can end on time. If I do this, git checkout, and we'll make this slide deck available online too, so you guys can download this. Working, second branch, git checkout B, working. It's switched to a new branch called working. I'm now on my new branch. I'm going to do this. I'm going to go vi second file .txt. I'm going to go insert. This is my second file. I'm just going to save it. Right, escape, quit. I'm going to do a git add. Second file .txt, git commit -m, adding second file to working branch. Okay, that's my commit. That's there. If I do a git status really quickly, the 30 seconds I have left, I typoed something, git status, you can see that I'm on branch working and there's nothing to commit because I already committed the thing. Now here's where the magic is. If I go to my Finder here, because you can see it there, that second file is there, right? Now, if I go over here and I go git checkout master, I want to switch back to the master branch. I switch to branch master. That file no longer exists on my working directory. I cannot see it. It's not there. The changes don't take effect. It's not affecting what's there, right? That's the power of this. So I could continue to work, be on master branch, do everything I want to do, but then switch back, or on working, switch back to master. Master is gold. It is solid. It's unaffected until I know the other one's good. And again, I'll just switch back. If I check it out again, check out master, or I wanted to do the other one, git checkout working. It's going to be back. Now that file's back because now the working branch is what's live in my Active Directory. So you start to see the power of this if you're working with other people. And this is that I don't want to share a file yet. I do. Just work on your own branch. You don't push it, right? You get the branch till it's done. And then you say, okay, now I'm ready to share this. Now I push my branch out, right? And that's really the right way to handle that. Okay, so that is actually, we are right at time. What I'm going to do is we'll get to Git remotes for those people that want to. In the deck, I will just show people very quickly. If you do download the deck, it has a bunch of references here for you. If this ever turns on live again. They're really good. If you want to become, these are things, all things that we talked about, but there's a reference manual. There's this Linux command line Bible. You can get it for free as long as you're logged in on the UCSD domain, because the library pays for it. Also, Stack Overflow has a great area for Git for beginners. That's a help area. There's a lot of good threads there, things that are good. And you can just download this from the website tomorrow and get these. And then some books that are all free and available online. The Git book, the Pro Git book. Really, really good if you want to be a power user. And then the last thing I will say is that you will also get via email from us a link to a survey. It's very short, very simple for this workshop. It's very, 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 very useful for us if those get filled out. So please take the time and fill the survey out and let us know, because that will help shape the class future forward and also help shape all of our offerings. So with that, I will close. I can hang around and field questions if people want, but that's the end of our time and the end of our content. So thank you for coming. Hopefully we'll see some of you for the Git for Teens in a couple weeks.